Good morning, children. Welcome back to our math session. Today's topic is exercise 12.2 of chapter 12 Exponents and Powers. So let we start. Expand large numbers. Let me just recap of expansion of large numbers. So we have learned that the exponents decrease as we move towards the digits on the right hand side, right? So let us take an example. Here we have 12,678. 8 is at the unit place, 7 is at the tens place, 6 at the hundred place, and 2 at the thousands place, and 1 at the 10,000s place, right? So this can be written as 1 into 10 raised to 4 plus 2 into 10 raised to 3 plus 6 into 10 raised to 2 plus 7 into 10 raised to 1 plus 8 into 10 raised to 0. So what do we see as we move towards uh, just on the right hand side, the value of the exponent is gradually decreasing, right? Similarly, you take one more example. This one is little bigger number. So in this case, how can you write this number? In this case, we can write 9 into 10 raised to 7 plus 2 into 10 raised to 6 plus 5 into 10 raised to 5 plus 3 into 10 raised to 4. You have all zeros after this, right? Here also you see that the same thing as we move towards the value of exponents gradually decreasing, right? Now let's see large numbers in standard form. Now let's see that how do we write very large and very small numbers in standard form. So you have already learned about write a large number in standard form, right? How do we write it? We express the number as a decimal number between 1 and 10 and then multiplying it by a power of 10, right? Let's see an example. For example, 24,000. So this is not the standard form, right? Because whenever you want to write it in standard form, you have to write it in the form of a decimal numbers between 1 and 10. So this is means this 24,000 is far greater than 10, right? So how do we do that? This number 24,000 actually means 24,000.00, right? That's how it means. So your decimal point is actually at the end of the number. So what we want to do? We want to shift the decimal point to such a place such that we get a decimal number between 1 and 10. So where do we shift it? We shifted 1 jump, 2 jump, 3 jump and 4 jump so that it becomes 2.4 into 10. We multiplied it by power of 10, right? So how much power of 10? How many jumps are you are taken here? So total 4 jumps. So it will be 2.4 into 10 to the power 4. This is the standard form of this number. Clear? The same way you can see one more example, that is 1, 2 and how many zeros? 5 zeros are there. So how could we write? Here, this one we can write as 1.2 into 10 to the power 6. Means we have to make it as a decimal between 1 and 10. So here we can 12, we can write as 1.2. Then after that, after decimal, you count how many numbers are there, how many digits are there. So here after 2, we can count, after 1, we can count that 6 jumps are there. Like, right? So the answer would be 1.2 into 10 raised to 6. Okay. In a similar manner, when we want to represent small numbers in standard form, there also the logic would remain the same. That is, we would still want to represent a number as a decimal number between 1 and 10 and multiplied by a negative power of 10. So that is the only difference, that is negative power. Okay. This time you will have a negative power of 10 will get, right? So let's see one example. Let's suppose you have this 0.000001 means 5 zeros are there, then 2 1 is there. Okay. So how do you write this? See, the decimal point is in the starting time, isn't it? Starting the point is there, right? So how many jumps you need to make so that you able to form a number which lies between 1 and 10? So obviously for that you should be in the decimal point after 2, right? So that it becomes 2.1 and there then multiplied by a negative power of 10. And what would be that negative power? That will be determined by the number of jumps that you have taken. So here we are doing 6 jumps, like means a point we are shifting to 6 jumps after this, the given number, right? So this would be 2.4 into 10 raised to minus 6. So that is the standard form of the given number. Clear? Now let's see question number 1 of exercise 12.2. Express the following numbers in standard form. First one, here you can see that in the question the point is in the first. That means it should be a smaller number, very smaller number. So the power should be, you have to remember that the power should be in standard form. The power should be in negative form, right? So you have to see that how could we make it? We have to make it as a number. It should be coming in between the decimal place 1 to 10, right? So here last 8 and 5 is there. So we can make it as 8.5. Now see how many jumps you required to reach at 8, right? So count the jumps. So here you are jumping 12 times. So the answer would be 8.5 into 10 raised to minus 12. Clear? Same way second question. Here 0. How many zeros are there? Yes, 11 zeros are there, right? So now see, how could we write? We can write it as 9.42 into 10 raised to minus 12. Why we are not writing 94.2? Because 94.2 is not in between the decimal number 1 to 10. That is why, right? So the number should be in between 1 to 10. Okay. So next one, 602, and how many zeros are there? 13 zeros are there. Okay. Now how could we write? We have to make first it is the decimal number should be in the form of 1 to 10. So here we can take 6.02 into 10 raised to, then count the numbers. Yeah, count the jumps. How many? After decimal, you see how many numbers or how many digits are there? 15 digits are there, right? So answer 6.02 into 10 raised to 15. Same way next one, 0. How many zeros are there? 8 zeros are there. So the answer would be 8.37 into 10 raised to minus 9. Next one, 3186, and how many 7 zeros are there? Right? So how could we write 3.186 into 10 raised to 10? Okay. Now see question number 2. Express the following numbers in usual form. It's already given the standard form. We have to write the verse opposite of that. Okay, 3.02 into 10 raised to minus 6. Minus 6 is there. The power is minus 6. That means it's a smaller number, right? So here one number is already there. So how many jump is required? Means how many zeros we can add? 5 zeros, because one number is already there. So 5 more we need. So the answer would be 0.000000302. 5 zeros and 302. That is the answer. Okay. Second one, 4.5 into 10 raised to 4. The power is positive. So we know that the point will move right side. So here 4.5 into 10 raised to 4 means how many zeros? Means 10,000. That is equal to 45,000 is the answer. Now 3 into 10 raised to minus 4. Again negative integer. So smaller number decimal will move left side. So 0. How many zeros will come? 7 zeros. Then 3. Because minus 8 is there. 3 is already there. Okay. So 1, 2, 3, 4, 5, 6, 7 zeros and 3. So answer is 0.000000003. Okay. Fourth one. 1.0001 into 10 raised to 9. Positive number is there, right? So you have to shift the decimal to right side. So here already 4 decimal number is there, 0001. Now we need 4 is already over, 5 more zeros. So add 5 more zeros there. So answer will be 10001000000. You can see that in decimal, the power is positive, then we are not putting the decimal numbers, right? So the decimal number will come in the end. So no need to put the decimal number there. But if it is negative power, then decimal number is coming in the left side. So there, surely we have to write the decimal numbers. Okay. Now next one, 5.8 into 10 raised to 12. So here 5.8, one is there, so we have to add 11 zeros, right? So 58 and 11 zeros should be there. Now sixth one, 3.61492 into 10 raised to 6. So first you see after decimal, now how many numbers are there? 1, 2, 3, 4, 5 numbers are there. So only you have to add 1 0. So the answer 3614920. Okay. Now third question. Express the number appearing in the following statements in standard form. First one is 1 micron is equal to 1 upon how much? 1 or 6 zeros meter is given. Upon means in down it is given. How many zeros? 6 zeros are there. So we can write it in the form of negative power. Means it is a smaller number, very smaller number, right? So the answer will be, yeah, in the standard form would be 1 into 10 raised to minus 6. Second one, charge of an electron is, these many zeros are there and 16. Okay. So how could we write 1.6 into 10 raised to minus 19? You count the zeros. Third one, size of a bacteria is 0.3 plus 3, 6 zeros and 5 meter. So how could we write 5 into 10 raised to minus 7? Now fourth one, small of a plant cell is 0.00001275 meter. How could we write 1.275 into 10 raised to minus 5? Thickness of a thick paper is 0.07 millimeter. How could we write 7 into 10 raised to minus 2? Okay. Now see question number 4. In a stack, there are 5 books, each of thickness 20 mm and 5 paper sheets, each of thickness 0.0016 mm. What is the total thickness of the stack? Okay, here the thickness of each book is given. First we have to find the thickness of 5 books. Same way, each sheet thickness is given. So we have to make the thickness of 5 paper. Okay, first see thickness of one book, that is 20 millimeter. So thickness of 5 books is equal to 20 into 5, that is equal to 100 mm. Thickness of one paper, that is 0.016 mm. So thickness of 5 papers is equal to 0.016 into 5, that is equal to 0.08 millimeter. Now you can total it. Total thickness of stack is equal to 100 plus 0.08, that is equal to 100.08 millimeter. Now we can write it in standard form. How could we write 1.0008 into 10 raised to 2 millimeter, right? Okay. Here we are completing our session. We have completed exercise 12.2 and this chapter also. Okay. So you have noted down all the questions in your notebook. Okay. Thank you.